Hello everyone, my name is Arthur Morris and welcome to Solving Multi-Step Equations. Okay, so if you looked at my previous video of solving single-step equations, you saw these same steps. So my equation solving process is to clear fractions if I have several fractions in an equation. And I clear my fractions by multiplying the entire fraction, the entire equation, by the least common denominator. My next step is to clear parentheses by using the distributive property. Collect like terms on each side if we have them. Get all of my variable terms on one side by using my addition property, and then all of my constant terms, which are the terms without variables, on the opposite side by using the addition principle. Collect like terms again if necessary, and then multiply or divide to solve for the variable to make it into 1x or 1y or 1v, whatever variable you're looking to solve for. And always remember that you can check your solutions by plugging your solutions back into the equation, the original equation, in the place of the variables. Okay, so let's look at a few examples. So this one we have 7y plus 10 equals 3y minus 2. So my goal is to get this to be 1y. Well, I don't have several fractions. I don't have any parentheses. I don't have any like terms on my left-hand side or my right-hand side. But what I do have are y terms on each side of my equal side. So the first thing I'm going to do is to move my variable terms. I'll call that MV. Move my variable terms to get those together. So I'll use my addition principle. So I like to get my variables on the left-hand side if possible. So since I have 3y here, to move this, I'm going to subtract 3y, and then subtract 3y from my left-hand side. So 7y minus 3y is simply 4y. Bring down the plus 10. 3y minus 3y cancels out. That's why we did that. So I have negative 2 left on my right-hand side. Now we want to move the terms without variables from the left-hand side to the right-hand side. So in other words, I want to move this plus 10 again by using my addition principle. So I will subtract 10 from each side. That will cancel out. So now I have 4y equals negative 2 minus 10. Negative 2 minus 10 goes deeper into the negative, so negative 12. Now remember, our goal is to make 1y. Right now I have 4 times y. I don't want to know the value of 4 times y. I want to know the value of 1y. So I will finish this off by dividing both sides by 4, because 4 divided by 4 is 1y. So y equals negative 3. Again, please feel free to pause if you need to. Pause the video. All right, example number 2. Don't have any fractions, don't have any parentheses, but I do have like terms on each side. For example, on my left-hand side, I have 3x and minus 5x, and on the right-hand side, I have a 1x and another 1x. So I'm going to combine my like terms first. So on the left-hand side, I have 3x minus 5x. 3 minus 5 is negative 2x minus 6. On the right-hand side, I have an understood 1x and another 1x there, so that gives me 2x plus 6. So now I see that I have variable terms on each side, so I will move my variables to get those combined. I have a positive 2x here, so to move that, I'm going to subtract 2x from each side. So negative 2x minus 2x puts us deeper into the negatives at negative 4x. Cancels. So once I get my variables on one side, I want my constant terms on the opposite side, so I need to move this minus 6. And how do we do that? By adding 6 to each side. So now I have negative 4x equals 12. Divide each side by -4 because, again, we want 1x, not -4x. So divide by -4, divide by -4, and x is equal to -3. So just going through the equation solving process is all we are doing. It's just a step-by-step process. Okay. Next example, we have -2.
Okay, let's take a look at this example. All right, so the first thing that we would want to do is to clear the parentheses. We would multiply -2 times those terms,
but we do
which is
have parentheses to clear.
1
Let's use our distributive property to clear
16
the parentheses.
minus 1
So we would
equals,
distribute the -2
clear those parentheses,
-2 times 3y, -6y.
-4y, and negative times negative make +8.
Minus y. The y was not in parentheses, so we don't distribute to that. -4 times.
All right, the next thing that we would want to do is combine our like terms. On the left-hand side, we have -8 and -1y, which gives us -7y plus.
So after we use our derivative property, we look for like terms on one side of the
right-hand side, same because I don't have any like terms over there.
We have this -6y minus under.
And we want to move our variables to get our variable terms together. So let's add 4y, add 4y, plus -3y plus 16 equals +8. Move our numbers to get our numbers to the other side on variable terms. Subtract 16, subtract 16, -3y equals -8. 8 minus 16 is -8. And last but not least, we will divide both sides by -3 to give us a +1y. And then negative divided by negative will make 8 over 3.
Numerical terms or the constant terms on the opposite side.
Okay, so just go through your equation solving process step by step, and you will arrive at the answer.
Subtracting 16 each side. So now I'm left with -3y equals 8 minus 16. That puts me into the negative. Example number 4 here, we have 16 times x plus 3 equals 4 times 12 plus 4x. So what should we do first in this problem? That's right, clear the parentheses by using our distributive property. So we'll use our distributive property to clear the parentheses. 16 times x is 16x. 16 times 3 is 48. On the right-hand side, let's use our distributive property again. 4 times 12, 48. 4 times 4x, 16x. Now, if you look at this closely, you see that there's the exact same expressions on each side of the equal sign. Let's go ahead and take this one step further. Let's go ahead and move our variable terms to get those combined. So I have 16x here, so I'm going to subtract 16x. I'll come over under my other x's and subtract 16x. Well, 16x minus 16x, that's nothing or 0, so I'm left with positive 48. Same thing go on the right-hand side, left with positive 48. Now, this is a special equation. This tells me that it does not matter what real number I plug in for x, I will always get a true solution. So since what I have left is true, when my variables cancel completely out and the statement that I have left is true, my answer is all real numbers. Now, if I would have gotten a false statement, say 32 equals 48, then that tells me that there's nothing that I can plug in for x that would make the equation true. Therefore, it would be no solution. Okay, let's look at one more problem here. All right, So we have 10x minus 2 parentheses x minus 7 equals 8 parentheses x plus 1 plus 5. So let's clear our parentheses by using the distributive property. So I'm going to distribute this negative 2 to each one of those. So be careful there. Then I'm going to distribute this 8 to each one of those terms. So after clearing the parentheses, what should we look for? That's right, like terms on one side or the other. And we do have like terms on the left-hand side. We have the 10x and the minus 2x. We also have like terms on the right-hand side with those regular numbers, the 8 and the 5. So let's combine those like terms on the separate sides. So 10x minus 2x, 10 minus 2 is 8x. And then 8 plus 5, 8 plus 5 is 13. After we combine those like terms, I see that I have variables on each side of my equal sign, so I'm going to move my variable terms to get those combined. So I have a positive 8x, so I will subtract 8x. Cancels out, leaves me with a positive 14. That cancels out, leaves me with 13. So here's another special situation. In this one, the variable terms canceled out. However, the statement that I was left with was not true. 14 is not equal to 13. That's not true. Therefore, there is not anything that I can plug in for the variable x that would make this equation true. So my answer is no solution. 0 with a slash through it means no solution. All right, hope you found this video to be helpful. Thank you.